Good morning, everyone. My name is Christos Argyropoulos, and I will be the moderator for this session. First of all, I would like to say a few things. I'm deeply honored and privileged to have been invited to participate as moderator of this session at the 15th Safety GALA virtual workshop, which organized by the Management Force Group. Today, in this session, we have great presenters and speakers. Before we start with the presentation, I would like to mention that Ms. Kaya will not be able to participate and present, but I will present instead of her. Before we start the presentation, every time that we start with a presentation, I will say a few things about the profile of the speaker. So please let me say a few things about my profile. Right now, currently I'm an adjunct assistant professor in health risk assessment at the School of Medicine at the European University of Cyprus. I hold an integrated master degree in chemical engineering from National Technical University of Athens in 2016, and also received another 2 master degrees in computational mechanics and mathematical modeling in modern technology and financial engineering from the same university. Also, I did my PhD and DIC degree at Imperial College of London in chemical engineering and computational fluid dynamics. From November 2015 and to May 2018, I was postdoctoral research associate in the Department of Chemical Engineering at Texas A&M and Mary Kay O'Connor Process Safety Center, Arcata. In general, I deal with my research interests deal with the development of processes and models for the investigation of complex phenomena in the field of process safety and risk assessment, public health, and environmental health and exposure. I have acquired extensive experience as project manager in several local and international research programs, and I have published more than 50 original scientific papers in international journals, books, and also I am a chartered engineer of Technical Chamber of Greece and Cyprus, and a member of the Social Economic Analysis Committee at the European Chemical Agency. This about my profile, and I would like to say also a few things for the first presenter, Ms. Elizabeth Kaya. She is a mechanical engineer. She gained knowledge in designing and creating a mechanical system and machine, as well understanding how the function interact with the environment. This knowledge applied by her in the occupational health and safety field, and had the ability to identify and mitigate potential hazard in machinery and equipment to keep workers safe. With a master degree in occupational health and safety, she has further developed her understanding of workplace safety, including risk assessment and management, occupational hygiene, and ergonomics. This allowed her to take a more comprehensive approach to ensure the safety of workers, which could be highly valuable in industry, especially manufacturing sector, as she working there. Throughout her career, she has shown an unwavering commitment to ensuring the safety and well-being of workers in various industries. Her expertise in mechanical engineering and occupational health and safety has been instrumental in implementing effective safety protocols and measures that prevent accidents and minimize risk. And please let me start with the first presentation. I'm sharing right now. I hope you can see my presentation. And as mentioned before, right now, I will replace Ms. Kaya for the presentation. The title is about the implementation of the system theoretic concept analysis in oil and gas industry. The outline of the current presentation is constituted by the introduction, which describes the motivation of the present study, the main objectives of the study, the proposed methodology, which is focused mainly on the STEP method, and the newly introduced STEC approach. as well as the appropriate material that were used for the implementation of the method, and of course, the description of the selected case study that we did. Finally, the results are presented and discussed together with their findings and conclusions. Main risk analysis and assessment methodologies are classified into three main categories: qualitative, quantitative, and hybrid methods. The first type of techniques that, as I mentioned, comprises well-known types of analysis. For instance, checklist, what-if analysis, and the hazard probability hazard method, among others. The second type of methods is specified on the safety level of the associated risk. Sorry, or an isolation, including also the well-known methods as the proportional risk assessment technique like PRAT and the quantitative assessment of domino scenarios. And finally, the hybrid category includes techniques, as mentioned, such as the fault tree analysis and event tree analysis, among others. Methods as HAZOP and failure mode and defect analysis, FMEA, are currently used when we have a safety critical process. Is new, or it has changed it. However, STECA can identify a wide range of hazard scenarios in the first stages of the development. As a result, a proper selection of options could be followed, such as the hazard will be eliminated or minimized. So STECA is based on the STAP method, as mentioned before, and by Levinson. This method invented at MIT by Levinson. And STAMP considers safety as emergency property, and therefore every tool based on STAMP, including STECA, studies its system as a whole. Okay, so the STECA is currently being utilized in the aviation industry and the emergency plan for the identification of loopholes. So the purpose of this study is to introduce and implement this type of process, STECA tool, into other systems such as the oil storage tanks in petrochemical process facilities and tank farms. The objectives of the present study are to learn more about the method and the technique to implement STECA in process industry, for instance, terminal depot, oil and gas marine terminals and refineries, and of course in many other sites, suggesting that the identifications of hazards can be improved. Secondly, it determines the measures which need to be followed in order to prevent or minimize the effects of potential accidents. Finally, this study attempts to recognize at the early stage of design possible errors, without affecting the subsequent operations of the system or process. So let's say more things about the STAMP methodology. STAMP is a continuous control task to place the required constraints in order to ensure that the system will go to safe adjustments. So it treats safety as a control problem of the systems and views system as hierarchical systems, as hierarchical structures with multiple control levels that each one can be represent constraints on the activities of the level below. On the other hand, STECA is a new technique that was introduced by Fleming in 2015, and it's based, as mentioned before, on the STAP method. This method is governed by the system theory principles, such as the system theory hierarchy and emergence, as well as the communication and control which are used for the construction of the system. STECA can help us to identify hazard scenarios that other methods failed to recognize in the early stage of the design. So the procedure of using the new technique STECA is similar to the system theoretic process analysis, STPA analysis method. Similarities of these methods are the following. For instance, identification of hazard and system level safety concerns, identification of hazardous scenarios. STECA also utilizes the following concepts. For instance, a process model, feedback control loop, hierarchical control structure, safety constraint, while the main steps of the method are, for instance, the identification of the system level hazard and safety constraints, the systematic control model development, and the system theoretical analysis of model. Of course, more details can be found in the PhD of Fleming, as mentioned before. And as you can see here, in very short way, you can see the methodology. You can see here the figure that I try to summarize the main concept, the concept of operation, the identify system hazard, how to identify the control concept, and the sequence of all of these. Again, the methodology, as I told you, is consisted of three steps. The first two I already mentioned and described it before. The step has to do with the find gaps or missing points of the procedure in order to detect them on the early stage or designing the system. Of course, the control concept separates the responsibility of each entity of the standard operation procedures, and the hierarchical order is identified. And you can see here on the right-hand side, the table with the checkpoints and the responsibility. First, you can see on the first column under the checkpoints, the controller, the actuator, the control process, the sensor, and each of these responsibilities. All of these are part of the methodology that we have to implement in order to identify lack of safety measures and to improve the current safety measures and risk. For the application of the analysis, the standard of operation SOP document of the tank farm system is required and analyzed using STECA. For the method implemented in an oil depot storage in Cyprus, unfortunately, I cannot say more information about that due to the confidentiality reasons. The high-level system hazards are identified, and continuously the high-level control structure with responsibility are also identified through the task steps of the tank farm system as described in the SOP. The high-level control structure can be changed from the start to the end as the task steps are followed. So, for the analysis, it is important to identify the high-level hazard of the systems and also to derive the appropriate safety constraints related to the hazards. So, examples of hazards for the tank farm system include the release of tank content, for instance, to the environment, disruption of flow of the tank content, among others. Okay, there are many scenarios that we can investigate. On the other hand, safety constraints are also based on the aforementioned identified hazards, as mentioned before. So, setting the safety constraints along with interactions of the system components can be controlled, restricted, or permitted. So, example safety constraints for the tank farm can be, for instance, leak or rupture of the pipeline, for instance, or instant release of the content of the tank, among others. Okay, so let's try to tell you a few things about the scenarios that we investigated. You can see on the left side the scenarios that we select, which are analyzed based on the use of the written procedure identification. Must be done according to 15 safeguards, categories, sorry. So the selection of the scenario is based on SOPs, according to the information that we had from the oil depot. And for each component of the system, a hazardous scenarios has been selected to be analyzed. So following the task steps of an operation, the high-level structure is constructed, as you can see also from the figure. For the first step, the terminal shift supervisor identifies the assets that are under maintenance or out of service, and also explains to the shift members the operation plan and the purpose of the shifts. Okay, so for instance, for the identification for the feedback of the shift member may be unknown, but this gap may lead to a potential flaw in the operational procedure. So it's very important to identify them. So then each component must be analyzed and in a sequence in such a way which can give us the order which component receives the order and the feedback. Then stack analysis is applied, as mentioned, by using the information from both the table and the previous figure that I showed in the previous slide with entities and the responsibilities. So each entity is analyzed, and also we try to see how it can contribute in a hazardous scenarios. So the details of the missing safeguards, for instance, additional information for the procedure and missing direction are presented in this table, as you can see. For instance, controller, terminal supervisor, process model, procedures, etc., etc. So, for instance, for the scenario, false alarms and shift members, which are the main two cases that we selected to present here, we can see that the concept of operation describes how the shift members check each component of the system and how the assistant supervisor is monitoring the alarms, okay, of the system based on his knowledge. So, but in the concept of operation, COO does not include information when a specific alarm can be ignored and how the condition that alarms can be override. So the second hazard scenarios can be also the error from shift members. As described above from the concept of operation, the shift members are responsible for the checks. And a hypothesis can be due to the heavy workload of the numbers, who may, as I mentioned before, who may then forget to check all the appropriate procedures. So according to the concept of operation, should describe a method for double checking the shift members. So again, here in this slide, we can see that for each hazard, as mentioned before, that have been identified, as safe constraints have been set. Several of them, you can see from here, is false alarms avoided or prevented, shift members mistake avoided or prevented, extreme weather condition, etc., etc. Okay, this is an initial, some initial ideas that we had, and also we confirm with people who work in the depot. So we try to prioritize them and try to identify them the best options for our study. Also, it's very important to mention here how we about the results of the test for the two test cases that we have, which means that we simplify the procedure using the method which is important and critical. So not lose critical information, instruction of how to react in hazard cases, for instance, when we have got a fire or tank linkage. So do not exceed or we didn't find information in the current procedure. Then the shift supervisor is not required to give a report to a superior, as it is described nor mentioned in the process flow diagrams. So a complete shift report is very important to inform personnel about any event per shift and proceed with the appropriate and corrective action where necessary. Finally, documentation of each inspection to the establishment should be kept and maintained for a time frame which indicate about existing standards or processes through the organization. So a simple way of recording such inspection is vital and important, and by the use of a checklist and listing the most possible errors and where they could occur in the premises. Then let's continue with the next one. It's also important to say that for the stack approach to be confirmed as reliable method, results from hazard methodology were used and compared with each other. We needed for these piping and instrumentation diagrams, known as PIDs, which are example of the data gathered and utilized for the comparison. Also, PIDs are diagrams showing the piping network of the facility. And for the method which we applied, an inspection to the facility was also made for a visual check and discussion with the supervisors and the technical staff. So the intention of performing a hazard, it was to review the design and to pick up design and design issues that may otherwise not have been found. So this is the way, one of the reasons that we implement STECA. Also, DCS problems are not mentioned in the hazard analysis, as we noticed. So comparing the methods, the major difference worth mentioning is the structure of analysis that we used. So hazard method used the PIDs, whereas STECA used the standard operation procedure documents. To conclude, it's important to say that the applied approach that we investigate is considered to be a new and useful tool and can provide identification of absent attributes in the safety procedure. The technique, the proposed technique, inspects thoroughly the system procedures from the prior step to design, while the intention of eliminating loopholes before its implementation has been identified and used properly. In order to evaluate the tool and its credibility, a comparison of the analyzed results, the obtained result, was made with the hazard method. Our results leads to identify the missing information that the procedures should have, or any safe hazard should be established in order to avoid major accidents. Also, the tool's intention is to assure that all safety procedures and responsibilities are examined. So the engineers of the system can also determine the reasons of errors, and also give effective constraints and safeguards in order to prevent the hazards. The implementation of the method in an already established facility can help us to identify any missing gaps in the safety procedures. And finally, it's important to note that such methods can be also helpful in early stage of design by avoiding any cost-effective changes after the designing process. Also, it can be concluded that it will be quite beneficial to apply the method in an already established facility in order to diagnose and analysis any of loopholes in the safety process procedures. A vital point to mention also is that such methods are useful in the early stage of designing the system, avoiding any cost-effective changes in the implementation process. And thank you for your time. And of course, I would like also to thank my student, MSc student, Elisabeth Kaya, for this work that she did during her postgraduate studies. And now, I would like to just to mention that we are going to have questions for each presentation at the end of all the presentations and speakers. Please don't forget to add your questions in the QA section in the chat box. And please let me say a few things about the profile of our next presenter, which is who is Dr. Nektarios Karanikas. Is associate professor in the Health and Safety and Environment discipline of the School of Public Health and Social Work, Faculty of Health, in the Queensland University of Technology. He studied an MSc in Human Factors and Safety Assessment in Aeronautics at Cranfield University in the United Kingdom, and he was awarded his doctorate in Safety and Quality Management from Middlesex University in the UK. Nektarios graduated from the Hellenic Air Force Academy as an aeronautic engineer, 19 years an officer of the Hellenic Air Force, and resigned in 2014 with the rank of Lieutenant Colonel. There, he served in various positions related to maintenance, safety and quality management, and including accident investigation, and he was also lecturer and instructor for safety and human factor courses. In addition to his academic qualification, Nectarios has held professional engineering, human factors, project management, and safety management credential, and has been a member of various national and international associations. He has published 2 edited books and several chapters, and has authored various peer-reviewed journal and conferences articles focusing on safety investigation and safety risk management. Finally, Nectarios has presented his work in over 90 events and actively volunteers in a wide range of scientific and professional activities. Nectarios, thank you very much for being here. We're very lucky that we have here. Please, the floor is yours, and you can share your presentations with the audience.
Christos, thank you so much. A very good evening from Brisbane, Queensland, from Australia. The time is 7 p.m. here. Very glad to be here with you online virtually. Thanks very much for the invite to the organizing committee. So my presentation today was inspired by the title of the event about rethinking safety. And it's like an injection, so it has nothing technical to share. It's more about a few things that, in my experience as a health and safety professional, human factors geek, but also as an academic in my courses I have encountered. I would like to share with you some distractions that might, let's say, exist out there, and what opportunities we can have to avoid such distractions. So one of the fundamental things when we discuss is whether we are talking about the same thing, if we are on the same page. And one of the first questions I pose to my students, industry professionals, but also students, young age, not still in the profession, is how they understand health, how they define safety, and what they understand as risk. And it's very interesting to see the responses that I get and to have the discussions with them, because I always say we can discuss about anything you want, but we need to be sure we're discussing about the same thing. So when it comes to health, more or less, all professionals and students align with the definition given by the World Health Organization, which you can see on the slide. So that's not a problem at all. However, when it comes to safety, and especially when we consult with literature, new or traditional safety views, doesn't matter, there's a bit of confusion out there. What is safety and what is not safety? So there's literature that says safety is a state of a system, which after we discuss and we argue, we conclude not, it cannot be, because if we're discussing about health and safety, and health is already a state, then how can a system be in two states at once? So we say safety might not be a state. So the next argument is it safety as a property. It's something that the system has. After discussions, we conclude again, it cannot be, because properties are something that the systems have, that you can see, you can sense, and they remain as characteristics of the system quite constant over time. Is safety a behavior? Is something that we do? It is not. Yes, we can do things safely, but we don't do safety. We don't say, I'm gonna do safety now. There is no such a thing as a behavior of safety. And the last, is it something we get or something we sense, which obviously is not, because we cannot physically sense. So safety is an immaterial construct. It's not something that you can create or generate. It's not a product, it's not a service. You don't provide safety, you don't produce safety. So what is it? When it comes to health, just an extension of the definition by WHO is not anything that is very, let's say, different. The only bits and elements you can find in this definition regards that health is something we need to survive, of course, for our well-being, but also to perform when we're talking about systems, because somebody can be physically or mentally healthy, but cannot perform within an organization for some reason. So maybe the health within that context, within the system, is not there. And intrinsically, when it comes to safety, if you think what safety really is, it is more about what we know or what we believe about the mechanisms through which we can prevent harm, we can prevent damages, which come due to exposures to different agents in the environment or interactions among those humans, environment, technology, and so on. So it's not something that we touch. It's not something we can measure. We cannot sense it directly. It's a concept that represents what we know and what we believe. And when we're talking about now interactions and exposures, because those are the conditions under which we actually function within our systems, and you have the safety management, you can say that we try to minimize harm and to maximize our well-being, which is indeed important. And interactions and exposures, as I said before, can happen because of elements in the natural environment, technology, equipment, other people, organizational procedures, and so on. Now, what we tend to forget, though, is that health and safety is not the only area in any organization that is very much interested in those interactions and exposures. You need to interact and you need to expose your system yourself to achieve several other areas like security, productivity, quality, economy, efficiency, you name it. So in reality, we want to be pragmatic and not, talking in an abstract way. We're not talking about safety management. We're talking about system management. Because once more, safety is not the only discipline, it's not the only area that is affected and benefit at the same time by those interactions and exposures. And if you want to be a bit more pragmatic, instead of calling safety management systems, it's more accurate to say safety in management systems. And this is a big difference. And words in our language plays a huge role in how we present the concept of safety and how we see ourselves positioned within an organization. So what do we mean? Safety in management systems. So that's an example from occupational health and safety. There are three areas that deal with exposures and interactions. Human factors or ergonomics is one, mainly with interactions. Occupational hygiene deals mainly with exposures. And occupational health includes psychosocial exposures and also individual characteristics. So those three together are the core discipline areas in occupational health and safety that we can use to protect ourselves and the system or prevent bad things. Everything around in any safety management system needs to serve the three areas that you see in the center. So if your audits, your investigations, your training, your communication, your campaigns, you name it, does not target to minimizing harmful exposures, occupational hygiene, or harmful interactions, which has to do with the human factors area, and does not consider the needs and capabilities and skills and the health status of the people, then it is a waste. If so, one of the tests that you can apply to whatever anyone says about a new safety service, a new safety idea, a new safety protocol, whatever, is how, through which paths, through which mechanisms, these new things or improved things will minimize harmful exposures and harmful interactions. And beyond that, how maybe they can maximize the good things. Now, going to another major area, risk. So those are the definitions that you can find in the standard, the national standard. When we're talking with professionals and students, the definition you see on the left, the risk source, and the one on the right, risk management, are more or less well understood. What we have troubles with is the definition in the middle. Risk is the effect of uncertainty on objectives. So if you really try to unpack this definition and try to do something, you cannot do much, because it is one construct, the risk, defined from through another construct, the uncertainty. So from an engineering perspective, not any other discipline area, maybe economics, this definition doesn't make a lot of sense, and students and professionals cannot really do much with this definition. I will get back to risk. First of all, let's go to the definition of hazard. More or less, if you read definitions about hazards, they claim that everything around us, everything in the environment is a hazard, like in this picture here. When you ask people, how many hazards can you see? Based on those definitions, I guess hundreds. But this is not a wise and healthy approach to safety. We cannot name everything around as a hazard. If we take lessons from hygiene and human factors, then we can understand that every agent in the environment can be a hazard or a threat, depending on the conditions, on the context. And if something has functioned as a problem in the past, as a threat or a hazard, it does not mean that it remains as a hazard or a threat forever. That in every context, in every condition. We have drugs, medicine. Medicine is poison. So in small doses, it can be beneficial. It's not a hazard. If you overdose yourself, then it can kill you. So the same element, the same agent, it can be hazard in one case, and it can be an opportunity and a beneficial factor in another. Just to give you a very, let's say, catchy example. And when it comes to risk, actually, what we mean when we're talking about risk is about the change, the possible change to the health status of a human or a system, if we're talking about risk about a system, because of those exposures and interactions with elements under specific properties. So if you use this definition, you can understand that you need to focus on those exposures and interactions based on the knowledge that you have. We know that this is risky, or the presumption that exposure to something or interaction with something could cause a problem. But not everything and not anything. Agents with specific properties. If the system, the health, of the individual or the system will deteriorate because we know it will, then we can name it as a hazard. If there's a possibility that this will happen, we're not very sure, then we can name it as a threat. And when it comes to risk analysis, the other big area is this product of consequences and the likelihood to estimate the risk level, which then is connected with those risk matrices. Tens of studies, very subjective, not very useful. Different interpretations, consequences on what, on whom? How do you average consequences from the past? So if you have one fatality, 2 serious injuries, 1 lost leg, 1 can't figure, what is the average of the risk? There is no such a thing there. And the likelihood, if you ask people, which probability do you mean here? Other people will talk about the probability of the event itself as a risk, or the outcomes of the event, or the factors leading to the event. So there is no even consensus about what we mean. Taking lessons again from occupational hygiene and human factors. What could be the risk level So it's a combination of how frequently we are exposed to something bad, how long its exposure can take, which, let's say, represent likelihood, roughly speaking. What are we exposed to? How big, how small, how toxic it is, and how much is exposed? Are we talking about one person? Are we talking about 5 people? Are we talking about a huge area in the environment or whatever? So if you take all those now dimensions, you can start playing with the frequency, with the duration, with the properties of the agents, of any elements, or the population exposed or interacting with the agent, to see how you can manage the risk and you can minimize. And in addition to that, of course, we need to take into account the controls, we say, actually, how much the system can withstand an exposure, a harmful condition, or recover from it, or counteract this condition at this time that is happening, but also within the time that it might have between those exposures or interactions. So to give you a more symbolic form, that's not an equation that you can apply in practice, just to show you in a more symbolic form, this is what we do with risk and what we should do. Instead of talking about uncertainty of objectives and any abstract thing out there, instead of trying to estimate and discuss about the likelihoods and consequences, here it is, and it's not mine. Those things are stemming from the combination of the knowledge we already have in disciplines like environmental health, like occupational hygiene and human factors. No rocket science, since, sorry, I don't know how much educated we are in the health and safety profession. Those are the things we should know and we should do. And the last point I want to make is about this hierarchy of controls when it comes to controlling the risk. This is a topic that you can find in any risk management course. And it's very interesting that it talks about the hazard. It doesn't talk about the risk. Now, as I said before, to try to eliminate everything, it's unfeasible, it's not economic most of the times, and it's not pragmatic. The fact that I was attacked by a shark here in Queensland doesn't mean that I have to annihilate all sharks on the earth. So that's nothing that we should focus on. It's more workable and honest to discuss about risk. So it's about me keeping my distance from the shark. It's not about me killing the shark, to give you to continue the example. It's about how we can remove those exposures or interactions, or substitute with something less harmful, or minimize the exposure. And if we cannot do that, then actually what we say through administrative measures is to people, this is the best we could do through engineering, which nicely Christos presented before, the engineering approach, how we can design a system early to minimize the risk. And actually what we say through administration and personal protective equipment is, guys, that's the best we can do today. Those are the resources we have. This is the technology we have today. It's now time, because we cannot control things fully, for you to fend yourselves. And this is a more honest approach. When somebody claims as an employer, as a system designer, that controls the risk through administrative and measures and PPE, personal protective equipment, this person is actually outside scope. This person, this entity is lying, because control from a system design and management perspective covers the first 3 areas that you can see there in the green color. When there's a residual risk, when we are not capable of doing more, then we ask people to fend from themselves. We ask people, to say, you need to get your gloves on, you need to put your hat on, your helmet, you need to follow the procedure, because if you don't do that, we rely on you now, we cannot design it better, then we'll have a problem. And that's why I prefer instead of talking about hierarchy of controls, to talk about the hierarchy of options. So this is everything from me. That's some food for thought, and I will be very happy to answer any questions in the end of the session. Thank you very much.
Thank you, Nectarios, for the very nice presentations and the terms that you explained us. It was very useful, and to be honest, even for people with expertise, it's very useful many times to see them again, to discuss and rethinking about approaches and ideas that we have in the past. And of course, we read in old books, as I can tell you. Thank you very much for your presentation again, once more time. We have got also some questions from your presentation, but we are going to discuss at the end of session, as we said, after all the presentations. So let's continue. Let's go with our next speaker, Konstantinos Marigas. And please let me to say a few things about his profile. So Konstantinos graduated with a Bachelor of Science in Public Health and Hygiene and a postgraduate diploma in Occupational Health and Safety from Loughborough University in the United Kingdom. He possessed several other qualifications within the health and safety field. He is an IRCA certified lead auditor in ISO 45001 and holds a City and Guilds qualification in machinery safety. And he's also a graduate member of IOS and associate member of IMA institution. He has been working in the manufacturing industry, especially food and drinks, chemicals, and telecoms, as a health and safety professional since 2016, and gained valuable experience from multinational organizations such as Coca-Cola, Intracom Telecom, and ITW. Currently, he's part of the WM Morrison supermarkets and the manufacturing division health and safety team, where he's overseeing health and safety for multiple food manufacturing sites in the United Kingdom. Please welcome him. And Konstantinos, the floor is yours. You can share your presentations.
Good morning. Thank you very much, Christo, for the introduction and for talking the audience through my background.
Okay. Konstantinos, the floor is yours, and you have got full 20 minutes, so don't worry, we have got time.
Okay, thank you very much, Christos. Apologies for any inconvenience this caused. We have some technical issues. I suppose these things happen when you are on a live streaming. Thank you very much, committee, for the opportunity to speak about Lotto, Lockout, Tagout. It's my first time presenting in the Safety Gala, and I'm very pleased about that. Obviously, if we can go to the next slide, please. But I think we will probably need to pass that because Christos already covered that. So my background is already spoken about. As you can see, I started my career from Greece. I moved over to the UK, which is where I still am based at. So if we can please move to the next slide and we go into the topic. Working within manufacturing, my background is 100% manufacturing, mainly within the food and drink sector. I will present the topic of lockout, tag out within a manufacturing business, and especially when it comes to machinery, safety and machinery hazards. So I'm working in one of the largest supermarket chains in the country. It's the only supermarket chain that it has its own manufacturing supply chain in the UK. And basically the business is the second biggest food manufacturing business in the UK. So compared to all the other supermarket chains in the country, it's the only one that produces their own fresh food. And basically they produce over 50% of the fresh food that is available basically in the retail stores that customers go to buy their products. So as a business, it's quite large business. They've got nearly 500 stores across the whole country, 7 logistics and distribution hubs, and 18 manufacturing sites. And as you can see, they produce basically pretty much everything in terms of fresh food, meat, fish, vegetables, fruits, bakery products, even flowers. If you can please move to the next slide. Thank you. Just to give you an overview and a basic idea of the health and safety structure and the health and safety department across the business, we've got the safety director sat at the top of the structure. Then we follow with a head of health and safety, and then basically depending on the division and the business unit that the business has, we split them into three: logistics, retail, and manufacturing. I'm basically part of the manufacturing health and safety team. We've got at the minute 4 group health and safety managers looking after a few different sites, manufacturing sites mainly, and each of the site, they've got either 1 or more health and safety people on site. The reporting line is something really important I need to touch on. It has been kept external, which means that the people on site, the health and safety people on site, report directly to ourselves and not to the site, not to the site management team. And that has been done intentionally in order to help with transparency and honesty, and when it comes to escalating health and safety issues. If you can please move to the next slide. So going into lockout and tag out, LOTO, because I understand and I appreciate that many other health and safety professionals attending this event might not be 100% involved or sure what LOTO is, or they might be working in a different industry where LOTO is not applicable. I thought it's probably useful to explain what LOTO is first. So LOTO stands for lockout tag out, and basically is a safety procedure that is used in order to ensure that dangerous equipment is properly shut off, in order not to cause any harm if it accidentally starts up again when we're doing maintenance or repair or any cleaning activities. And basically, lockout is used and followed by using a padlock, as you can see. And the tag out stands for the tag that you can see on the right-hand side of the screen. And it's basically used in order to make everybody aware in the area that the equipment is currently isolated. We put the name of the person who attached the tag, the date, what the activity is, how long it is supposed to take to last for, and the contact details in case something goes wrong and people in the area need to inform somebody. So we'll move on to the next slide now to explain why we do it. And as we said, it's basically because of the need to prevent unexpected startup of machinery, to isolate equipment in order to do cleaning, maintenance, repair, or if we need to safely remove a blockage or a jam on the machinery or on the manufacturing production line that we have. And we need to do it in a safe way. Otherwise, we'll end up having an injury or somebody trapping parts of their body, their fingers, maybe, hands, etc. Thank you very much. If we can move to the next slide, please. Thank you. So how do we carry out lockout tag out? In general, the principle is that we actually prepare the machine for shutdown. We notify everybody who might be affected, so people who are working on the manufacturing line or on that specific piece of equipment. Then we proceed to shut down, basically just turning the machine off, switching the isolator switch off, then placing the padlock, as we see on the last slide before, and the tag in the energy isolating locations. Release any stored energy that might be mechanical, it might be pressure, electrical energy, because we don't want to end up having, excess stored energy later on when we actually carry out the repair or the maintenance or the cleaning activity. Somebody needs to verify the isolation as well. And then we continue and perform the task that we are interested in. What is very critical is that we need to get somebody who is trained, competent, and they know what they're doing. Nobody without any specific training is able to do isolation. So mainly across the industry and specifically within our business, we have said that people who can do isolation, basically lockout, tag out, is only engineers, hygiene operatives and machine operators. Can we move to the next slide, please? Thank you. Something very critical to remember, and we'll see that later on, is that one person needs to have one lock and one key. So you cannot end up having one padlock with multiple keys or one padlock shared between many people for obvious reasons. If we end up having more than one person working in the same machine at the same time, then there is a specific procedure that we follow, which we'll see later on the presentation. Can we move to the next slide? Thank you. So the case study within our business, moving on now, what was the problem? Because obviously in order to be a solution, there must be a problem. So the problem that we identified is that last year we identified a trend, especially with machinery related accidents and incidents across many different manufacturing sites. So it wasn't a specific case where we had an issue in one of our sites. It was multiple issues across multiple manufacturing sites across the country, doing different products and different operations. So to be specific, we identified 32 events last year, mainly involving entrapment by machinery. And that actually might be a blockage. So somebody attempting to clear a blockage themselves ended up trapping their fingers between other parts of machinery. We had colleagues not following the full isolation procedure when they had to enter, for example, automated machinery like a robotic palletizer area, where you basically need to isolate the machine before you enter so that it doesn't start up. And also something else that we identified, and it's quite interesting, is that people did not always complete the pre-start check of the machine after maintenance, repair, or cleaning activities taking place, which means that when they start using the machine again, there might be a missing part, missing bolt, missing guard, and mainly because of the lack of pre-start check happening again, they didn't realize that. So that makes the machine again unsafe. Can we move to the next slide? Thank you. So following the investigation that we've done, which was quite thorough, and also by trying to understand what happened, we found and we agreed that the causes of the problem are as follows. So basically, people were not always following the LOTO procedure because they wanted to prevent line downtime. They wanted to help the site team reach their objectives and the targets when it comes to volume and production. And they think that when we ask somebody, who is qualified or a member of the engineering team to do isolation for us, it will probably take time because they might do something, different on that time. They might be working in a different maintenance task, so they might need some time to come over here and do the isolation for us. So there were cases where team managers and unskilled colleagues preferred and decided to do basically machinery blockages and clear them themselves without following the isolation procedure. There is the belief that it won't happen to me because it's a simple job. It will only take a few seconds. So I don't really need to follow isolation procedure for the whole machine. Site did not always have the time, as we said before, to follow isolation policy. Sometimes the isolation policy and the LOTO policy wasn't the same across all sites, so it was inconsistent, and that created confusion between sites, especially because we are a big business and we have multiple different operations, and we get sometimes people working across a few different sites. The isolation procedures were not specific to the machine. So it was an isolation policy at the time, quite generic for everybody, not specifically for the machine that we intended to do isolation for. We didn't have anybody verifying the isolation that has taken place. So at the time, we basically relied on the person doing the isolation to then continue to do the maintenance without somebody else checking that the isolation has done correctly, if that makes sense. Sometimes we found that equipment, padlocks, keys, tags were not available always to the sites and at the correct amount as well. And to conclude, there was a general poor safety awareness about the topic of machinery hazards, machinery-related accidents, lack of understanding of what can go wrong, how bad it will be if it goes wrong, and general risk perception was quite poor. Can we move to the next slide? Thank you. So what actions did we take as a business? I can't see everybody right now, but I think I'm still live. Am I, Christos?
Yes, of course.
Yes, okay, right. So what actions did we take as a business following what we found, all the causes? We started again with education and training. So we revamped the material that we had, we made it better, we put some real case studies and events from incidents that occurred within our site so that we can actually speak to the colleagues on sites and they can instantly think about the equipment and the machinery that we have on site, and they actually feel a lot more comfortable with what we are talking about to them rather than using examples of accidents happening in other businesses. We got involved all different functions in terms of hygiene, quality, engineering, in order to get the buy-in and understand their needs and their expectations as well. When it comes to group lotto, it's something that I spoke at the stats before on my presentation. We basically introduced group lotto in cases where we had more than one people working at the same machinery at the same time, and that involves and includes contractors as well as our own engineers. We revamped the importance of pre-start checks, and we created a pre-start check must list. So there are things that when we do a pre-start check, they need to be there, and that was basically clarifying again who is responsible to complete the pre-start check, when they need to be done, what they need to do if there is an issue with the machine, and some usual areas of concern. So for example, e-stops that should be on the machine and should be actually working, not just present, bolts that must be there and fixed, guarding as well. So there was a must list created and distributed across all sites to help them do the pre-start checks correctly. We launched a new slogan, think safety, think machinery safety, and we put some tags and stickers on machinery, and we created new boards just to get the engagement and get the interest of everybody with creating some visual material. We had a dynamic risk assessment system in place, but at the time you couldn't really get lotto or / isolation done as part of the dynamic risk assessment. So basically we changed the format, and we included lotto moving forward as part of the risk assessment format that we use, the dynamic risk assessment format. We created color-coded padlocks. So it depends on the line and depends on the function. So for example, engineering would now have their own color on the padlocks. Cleaning and hygiene team would have a completely different color so that they're not mixed up. And also each line would have a board with their own padlocks as well. We put a new procedure in place for verification of lotto getting done by somebody, by a second person. Basically somebody going on the line checking that isolation has been done properly and has been followed before we proceed with the task. Contractors were made responsible for their own padlocks and their own lotto procedure. So if we had somebody working on site, basically they had to bring their own equipment in and use their own padlocks. We didn't provide them with our own. And something that we did to improve behaviors mainly and allow people to challenge themselves and challenge their colleagues. We had a behavioral observation system in place, but at the time, Lotto wasn't included. So now there was a new option of doing a behavioral observation for the Lotto policy and the Lotto procedure, and if it's followed on the line or not. So if we can please move to the next slide. Thank you. I've got a video now, which we basically used on our presentation. I'm not sure if we can see it right now here, because we had that problem with the slides previously. If we can run the video, that would be actually very, very nice. Otherwise, I suppose we'll just move on. So we wanted to make it a bit more visual when we delivered the educational piece. We showed 3 mini videos, which unfortunately I think we can't really watch them right now. Only half a minute, so 30 seconds video, basically showing what happens if somebody does not follow Lotto and does not isolate the machine, like what's the consequence. And basically there was somebody getting trapped into the machine. Just to make it very visual and allow colleagues and everybody on site to have like the reality of what can go wrong, the consequence. Then we had on the next video that unfortunately, again, I don't know if we can see, what happens when somebody is following Lotto procedure and everything is safe and the machinery is isolated and it's all good. You can safely work on it and complete your task. And then on the next slide, we had a group application example where basically we had 2 more people working on the same line, on the same machinery, completely different tasks though. So somebody was doing maintenance in one specific part of the machinery, somebody else was doing a bit further down the line, but it was still part of the same line. And basically we wanted to show them the consequence of only using one padlock. Because remember, we had one person, one padlock, one key, if you remember my slide previously. In that case, we had 2 people and it was only one padlock used. So basically we want to show them what happens if the first person finishes the job, they remove the padlock, but you've got the other person still working on the line. So potentially somebody might start up the line by accident. But yeah, unfortunately, we can't watch the videos right now. It's a shame, but I suppose these things happen. If we can move to the next slide, please. This is an example of some of the isolation boards that we use, and they are all based in different locations, in different lines as well. We've got the first one from the engineering workshop, and again, you can see they're color-coded, and they are, again, for different machinery, mechanical and electrical isolation as well. And the other 2 are just some examples from boards and lockout stations from the lines. The one at the end on your right-hand side is for cleaning. So it's supposed to be used only by the hygiene teams. And you can see also the tags that we use. Also in the middle photo, you can see we've got some red things with holes. Let's say, I don't really know how to describe them. They're just below the padlocks that we have next to the tags. And basically these are used for group Lotto application, as we said. If we can move to this next slide, please. Right, thank you. So on this photo, basically after the revamped education and the training and all the actions we took, we thought that everything is going well because we didn't really have many accidents after that. However, all seemed to be going well until we saw somebody. I personally saw somebody during an audit I did, a shop floor walk around, somebody removing guards and having the machine working, like conveyor belts were moving and everything. And basically they were trying to do cleaning when the machine was live. And when I challenged them, they argued that sometimes in order to do the cleaning properly or do any adjustments, on the conveyor belts or machinery parts, you can't really physically isolate the line. You still need the line to be moving. So we realized that our approach was a bit wrong. So if we can move to the next slide, please. Yeah, as I said, clearly our approach didn't work as we wanted it to work. Some of the machinery parts had to be cleaned properly and to be maintained properly and to be adjusted properly. The line had to be running. So we basically had to change our approach. And you can see what we did in the next slide. So as you can see here, we engaged again with the departments, with everybody, but this time we were on the shop floor. We were monitoring and observing the activities as they happened, and we created a risk and task-based approach, which means that for every single machinery, we created a risk assessment specifically for that machinery and a safe system of work or standard operating procedure, SOP, basically very specific for this machine. And when there was a case when we had to allow the machine to be running, we did put additional controls in place. So we barriered off the area, segregate the area. We only allowed 2 people to carry out the task. So basically they had both to be trained and qualified and competent in lot awareness and machinery safety in order to do that. Whenever there were parts of machinery that were not required for the task, we could proceed with isolation. But when it comes to cleaning, for example, by following the hierarchy of controls or of options, as Nectarios mentioned previously on his slides, we tried to eliminate or decrease as much as we can or find an alternative, for example, for the cleaning task. And in that case, for my example, using the jet wash, we can do non-contact cleaning, basically allow the machine to run, incorporate it, include that on the risk assessment and the safe system of work, but allow the non-contact cleaning. So basically there wouldn't be any contact with anybody and for anybody, during the cleaning process. So there wouldn't be any hazard to be realistic. Moving on to the next slide, just to tell you where we are right now. So what is the picture right now after our new approach and all the actions that we took? So far, we've got 7 events for the year, and they're all minor. When I say minor, they're mainly minor cuts. So somebody maybe cutting their finger slightly when they are moving a bit of product outside of the line due to a jam or a blockage. We don't have any injuries due to maintenance, repair, or anything major when it comes to accidents. So I think that it's a big step up and a big success compared to where we are in the beginning with 32 quite major accidents. So I think we're going towards the right way. And of course, we still monitor and we keep an eye on what we're doing and how we do it. If we can move to the next slide, because some people might think, is it all about accident reduction? We got other benefits, and that's the best thing out of it. By following this process now, and by re-educating people and getting everybody more involved and getting the buy-in and the engagement from colleagues, we had other benefits. So we increased employee morale. People now feel more safe. They're working in a safer environment. They believe that the business is doing something good for them. We genuinely care about them, and they can see that. And of course, they're going to return that back by putting more effort in, which will, overall increase the productivity. The colleagues will be happier. They will be motivated. So they will go the extra mile. The engagement has increased. We have managed to build trust, better relationship and transparency between the sites, the management teams, and the colleagues, across all levels. Absence rates, of course, are lower because now we don't have so many accidents. And if we do have, it's a minor cut compared to a big major accident which will have lost time. Of course, we comply now fully with the legal requirements when it comes to isolation and machinery. And as a result, we've got less threat of legal action. And that's again from the authorities, but also from a claim coming from a person. Lower accident rates. And overall, we started building a better safety culture, controlling the risks better, and have a positive mindset, across all sites and across all colleagues. So somebody now might ask, if we can move to the next slide. And you press another one as well, because I've got an animation. So why do we perform Lotto? Why do we really do it at the end of the day? Yes, all of that we just spoke about, it's very nice, very interesting, very good. But in the end, why do we really do Lotto? And why do we really need to be safe at work? And I think if you go to the other click as well, you will see why. Because at the end of the day, we all want to go back home safely. And we all want to go back home to what we love. I think that's the message for today. So thank you very much. I appreciate your time. I hope you found it interesting. And you can see my contact details. I'm also available on LinkedIn if anybody wants to stay in touch. Thank you.
Thank you very much, Kostadine, for the nice presentation. And we have got few minutes until the end of the session. Hopefully, we managed to finish and complete all the presentation on time. Even though we have got some problems, issues with the connection, but still where everything was perfect. So there is one question here that I have that we can ask for Nectarios. So Nectarios, the question is, how would you connect safety management systems with sustainability? Would you approach a sustainable safety systems or safety systems supporting sustainable business or something else?
Why and or? Yes, I support all those together. First of all, every system must be sustainable by itself. So it's very important for health and safety professionals to present and design and implement sustainable solutions. You don't want to apply any controls. You don't want to run any programs that, first of all, harm the environment, and second, waste resources. Now, at the same time, the safety management system can support sustainable business, because when you have people who are healthy, who feel safe, nicely, Konstantinos said before about this feeling of, I'm safe in this environment, meaning more motivated, more productive, then I really go to my work and do my best, then you have sustainable business. I don't know what are the or could be there. Just to note something, however, that we, I think, tend to forget. Safety is not the business objective, meaning that businesses do not create safety, do not do safety. It's not something they achieve. Safety is a legal and moral obligation. It is something that we sometimes, when we talk about safety, we don't acknowledge and we tend to ignore. So as an obligation to the society, to other humans in our environment, and of course the law, it can indeed support sustainable systems. I hope I answered.
Thank you very much, Nectarios, for your answer and your comments. Just let me just read from our friend here in the chat room, Mark. He's referring about, I think it's more like a remark, not a question, or a comment, you can say, to the presentation by Konstantinos. So I'm reading the comment by Mark: hierarchy of options, excellent approach, a lot of food for thought. Konstantinos has reminded me of the days that I was chasing people and educating them on the value of not circumventing limited switches. A good, frank and down-to-earth presentation, denoting increase of moral supported by real-time metrics. I don't know, Dimitri, I don't know, Konstantinos, if you want to comment on this or say something.
Yes, Mark, thank you very much. I think that was actually the whole point. And when we delivered the presentation and the slides and the revamped and reviewed education and training material to the colleagues, just bear in mind that we have probably more than 10,000 colleagues in manufacturing. So we're talking about a large audience. And of course, it was different cultures as well, because we have people working here from all over the world, coming from all over the world, originating from all over the world. We actually try to be to the spot, like very specific with bullet points, consequence, what's the problem, what can go wrong, and why do we need to improve. And we try to focus at the end of the day that it's not about protecting the business, from the liability, or decreasing the cost of a claim, or complying to legal requirement. At the end of the day, it's about yourself being safe at work. Waking up every morning, going to the place of work, and thinking that I'm currently in a safe environment. I can do my job. I can do it in a good, as the best I can, and then go back home safely, because that's what we need, and that's the ultimate goal. And of course, again, the moral will, increase. Everybody will be happier. And in order to get to the safety culture that we want, to the level of the safety culture that we want, we actually have to focus on the human behavior and the human psychology, and not just, the compliance element and, be the strict policeman type of health and safety professional that you need to do that, because if you don't do it, you'll get a punishment, you'll get a record of improvement or a disciplinary action. It's about passing the message to the person why it needs to be done correctly and safely.
Thank you, Konstantinos, for your additions. So we have reached at the end of the session, and we just only few minutes late compared to the initial program. I would like to thank all the speakers for the very nice and comprehensive presentations and for their useful comments and suggestions. So again, once more time again, I would like to thank you, Nectario Karanika, and Professor Nectario Karanika, and Mr. Konstantinos Mermigas for the very nice presentations. And if we don't have any other comments from our audience, I would like to thank you all for listeners and participate to this session. And I hope that you find very useful the networking break that is following up. One more time, thank you all of you. Have a nice evening.